Hello everyone, my name is Viraj and today we'll be looking at the seventh problem from the CP-31 sheet by TLE Eliminators under the 900 rated questions. Let's go. So I'll be moving on to my CP-31 sheet over here, ticked off my 900 rated parameter and the seventh problem balanced around. Let's open this. Okay. So you are the author of a Codeforces round and you have prepared n problems you are going to set. Problem I having difficulty I. You will do the following process. You remove some possibly 0 problems from the list and then you rearrange the remaining problems in any order you wish. A round is considered balanced if and only if the absolute difference between difficulty of any two consecutive problems is at most k, that is less than equal to k. What is the minimum number of problems you will have to remove from so that the arrangement of problems is balanced? Alright, let's generalize this problem. We have read this. So you are talking about an array over here. You're talking about an n-sized array and I'll call this array A and you have the numbers A1, A2, A3, A4, so on till n. Now you have one more variable that is called k, and what is the meaning of this? They're calling something known as a balanced array, alright, or a balanced sequence of numbers. A balanced sequence of numbers is numbers basically. If let's say I take up some balanced sequence, let's say I'll call this some numbers B1, B2, B3, so on, so on, so on. Like this sequence of numbers is balanced if I take up any two consecutive elements. If let's say I take up two consecutive elements B1, B2 or B2, B3 or B3, B4 and so on, so on. So if I take consecutive elements, the absolute difference between them is less than equal to k. So I can call this as bi. If let's say there's a random number bi and then let's take the next number bi plus 1, just two numbers I and I plus 1. If I take the absolute difference, this is less than equal to k. So this is what is the definition of k, and this is what is called a balanced sequence, balanced arrangement of numbers or balanced numbers in an ordered line. That's all we are talking about. Now, given this array, it might not necessarily be balanced, of course. So we want to balance this array out. To do that, you have been given some power, some operations you can perform, and that is one operation is you remove some element from this list. So you just say, okay, I wish that I would remove, let's say A2 or let's say I remove A4 and so on and so on. And then when I have done whatever removals I want, I can also rearrange the numbers however I like. So it's kind of a very good power they have said. You can just pick up the numbers key from any of their current position, they just move them around and create any sort of an arrangement you want out of the existing numbers in the array. So this power that is given to you, it's basically an operation, and out of these two operations that I mentioned, this above operation, that's the removal of some numbers from this list, is what is getting counted. This is actually an operation we want to minimize. So the question effectively is, how many minimum number of problems or minimum number of numbers you want to remove from this list, so that you can guarantee that after this, if I just rearrange or even not rearrange, if I keep it constant, doesn't matter. If I remove some numbers, after that I know that my arrangement is balanced. That is, if I now pick up any two adjacent numbers, I am getting an absolute difference less than equal to k. So if let's say I remove OP amount of numbers, I want to minimize this value. I want this to be as low as possible. And then of course they have asked you to report that value. So I have to report the minimum number of problems I wish to remove. Alright, so I hope the problem is clear. Let us see some sample case and understand this much better. So let's say I'm talking about this case over here. This is 1, 2, 4, 5, 6. So what are we saying over here? Like, I'll take this to a new page. Your array is 1, 2, 4, 5, 6, and you want k equals to 1. That is, you want adjacent differences to be less than equal to 1. So ideally, if you want minimum removals, we can remove 1 and 2. If that happens, we get something like a 4, 5, 6. Now, I don't want anything to be rearranged in this because I can very well observe even right now, if I take up adjacent numbers, this is like 4 and 5, the absolute difference is 1. If I take 5 and 6, absolute difference is 1. So of course 1 is less than equal to 1, that is actually k. So I know I'm good to go, and the number of removals you did was actually 2. So you report your answer to be 2. Arguably you cannot do anything better than this. You can cross verify this through your pen and paper. And now if you have understood this case, you can actually do a manual checking on the other cases also to figure out which numbers are we actually removing, and that might be very helpful to understand the sample cases. So I hope the problem is clear. Problem is very simple. Just find the minimum number of removals. That's all you can summarize the problem to be. All right, great. Let us discuss what would be the expected time complexity in this problem so that I know what ideas should I actually go ahead with and can I create a brute solution or not. So I know by fact that 1 second allows me 10 power 8 elementary operations. And in this problem, I have been given basically 2 seconds for every test. So if I write this like this, one test is allowed 2 seconds, which means it's actually allowed 2 into 10 power 8 elementary operations. Now, effectively, we would want to calculate the number of operations we can do for every test case that is denoted by the variable t. But there's actually a very important line written over here, that is sum of n over all test cases doesn't exceed 2 into 10 raised to 5, which means that we are not actually bothered with the time complexity for every test case, since overall when we club every test case's n value, we don't exceed 10 raised to 5 limit. I can actually consider time complexity with respect to the test, as in what is an upper bound I want to create with respect to 2 into 10 power 8 elementary operations in one test. All right. So that means now n can be noted as 2 into 10 raised to 5 order, which is actually given in the problem. If you go back over here, this is actually given to us. So if I assume that n was the main player in my time complexity, then I can create solution that looks like O of n, of course. Even I can create solution that looks like O of n log base 2 of n. This will still remain or keep me within 2 into 10 raised to 8 limit, but I will start getting a problem if I create solutions like n square. So O of n log base 2 and O of n so on. If I go even down to even a constant time complexity, all of this is working. All of this will fetch me an accepted solution, assuming my logic is right. But this is a problem. This is an upper bound for me. And this is my expected time complexity discussion, because it's hinting me that, okay, create solution that looks in this order. Don't go for a very high brute solution in n square orders. You will start getting wrong answers, or specifically you will start getting TLEs. All right, great. So now let us discuss the main crux behind the problem. How do we start solving this problem? So let's look over here at a very important operation. You can rearrange the problems any way you like. This is very important. Basically, it's giving you the power to rearrange any way, and it's not even getting counted. Those operations are not getting counted. So this is very, very helpful. What I can do over here is ask a simple question to myself. What is that one such order of an array where I know that consecutive elements difference will be as low as possible? I'll write this question down and you can look at this question briefly and try to answer this yourself. What is that one order of the array where the difference between consecutive elements is as low as possible? And the answer to this is actually very, very easy. It can be visualized also. Of course, a sorted order. Meaning, if you have an array initially, that is like A1, A2, so on till AN. If let's say you sort it out, that means you make sure that A1 is less than equal to A2 is less than equal to A3, so on. I'm just taking a general case when you sort it thus in increasing order, less than equal to AN. Then you know that if I now calculate the adjacent differences, like differences in A1, A2, A2, A3, A3, A4, so on, they will be as low as possible. The difference between A1 and A2, if let's say that difference is D1, and let's say if I would have not sorted them and initially let's say A1 was paired up with A3, then A1 being farther than A3 or A1 being much more lesser than A3, you know that this difference D2 is larger. You know that the difference over here is closer and the difference over there is larger. That means D2 is actually greater than D1. It might be equal to also, but it's definitely greater than equal to D1. So will you want to do that? Remember, the idea is the differences should be less than equal to K. If I want to make sure that my differences are less than equal to K, it would be greedily ideal that I make my differences initially go as low as possible I can. If that is not fulfilled, then greedily I might start getting answers which are not right. So why not using the second power, which is not at all costly, it's basically free, I should sort my array initially, or rearrange the elements in such a way that I have the sorted elements, and then I know I have made sure that the consecutive elements have differences as low as possible. Now, rest condition is up to me, that I have to check whether the differences have gone less than equal to K or not. That's a separate next part of the problem. But right now, greedily, I have made sure that yes, the array has achieved a case where the consecutive differences are possibly the lowest. So this is my argument 1, that you have to sort the array. Argument 1 is sort array. I hope this should be clear. Now let's come to the second part of the question. Assuming that now you have understood this visualization, you can pause the video and understand this. If you visualize this part that, okay, consecutive differences have now gone as low as possible, what do we want to do? We want to basically get the consecutive elements which I feel have differences less than equal to k. That's all there's actually left to do. So I'll note this down. I have the numbers again with me. I have a1, a2, a3, a4, a5, so on. Let's say a6 also till an. Now let's just jot down some point. Let's say the difference between these two numbers are d1, then this is d2, then this is, let's say, d3, then let's say this is d4, then let's say this is d5, and so on. Now, when I have noted these differences down, I effectively want these differences to be less than equal to k. So let's just say something. Let's say that this difference was less than equal to k. Let's say this difference was less than equal to k. Let's say this difference was greater than k. Let's say then this difference was again less than equal to k. Let's say again less than equal to k, less than equal to k, less than equal to k. Then let's say greater than k. And let's say this is where we stopped. So you can just imagine that this is what the highest limit was, the array. So basically I jotted down the differences. Now ask yourself, you have to find the minimum numbers you can remove. If you want to find the minimum numbers you can remove, what are you effectively trying to find? Can I say I am trying to find the largest subarray where for all consecutive pairs difference is less than equal to k? Am I trying to do this, or will this be beneficial for me? Argument is yes. Why? Because if, let's say, in this I'm able to identify that the largest consecutive differences which are less than equal to k is this segment. Basically that would mean somewhere around 5 elements, because these are 4 differences, so 4 differences come from 5 elements. Somewhere around 5 elements would be exactly those bunch of subarray. This would be sort of an subarray from here to here, which has all the consecutive elements giving you a difference less than equal to k. Now anything beside this is not beneficial. If I talk about the rest of the elements, a1, a2, a3, let's say this an element, are these beneficial for you? Of course, they're not beneficial for you because they are not contributing to the answer and they are getting differences which are greater than equal to k. Preferably over here, the difference was less than equal to k, agreed. But then this segment length was less than what was the highest segment length you can find. Which means if I'm able to get now the largest subarray or segment length, continuous segment length to be specific, where the consecutive pairs have less than equal to k difference, then if I call that segment length as L, then what is my answer? My answer is basically total number of elements n minus L. This is the value as my answer. This is the actual problem. So imagining that if this L segment of numbers is what you save, all the rest elements is what you remove. That is what you get counted in. That are the number of operations you perform. Hence, you directly calculate that by maths. The rest over numbers would obviously be in count of n minus L. N being total numbers, L being the numbers you save. So I can call this as total numbers, and this is the numbers I save. Numbers I save. So once I've done this, of course, it makes sense that I have stored up, I have created you can say sequence of numbers which have every consecutive element as less than equal to k difference, and I have removed other numbers, they are not useful to me, and I have made sure that they are minimized since I have made sure my segment length was maximized. So it was as high as possible, largest being the term over here, hence this term is as low as possible, lowest possible. Okay, so I hope this is clear. This is the whole problem. Now you can pause the video, try to give it a 2 minutes thought and get this idea of the largest subarray, and I hope the problem will be much more clearer to you. Now, what comes next is the implementation. How do I find this part? So of course, step number 1 was clear. I sort this array. To do this, all you have to do is run a simple STL sort function and you will get a sorted array. But then we are trying to find the largest subarray, or to be specific, I don't even want the numbers. I just want the length of that subarray which has all consecutive pairs of elements, as difference less than equal to k. So to do that, we have a very neat trick in our pocket, which is actually called the counter and reset technique. All right, it's like a counter and reset technique. It's very famous actually. It's where we actually maintain two variables. We can maintain a counter variable, I'll call this C, and we maintain an answer variable, which we start off with some initial value also. And then what I want to do is basically I want to check two consecutive elements. When I feel that two consecutive elements are getting a difference less than equal to k, I'll make my counter increase by 1, else I'll reset it to back 1 again. This will help me gather all the exact segments for which I was getting less than equal to k consecutive pairs difference. And out of those, I will always keep my answer variable to be maximized with respect to this counter variable C. So that would make sure that when I come out of my final loop, the answer variable stores the largest length or the largest subsegments size for which consecutive pairs of elements had difference less than equal to k. So this is the whole technique that I want to follow in this problem. All right, so let us do one thing. Let's take a sample case once again and run our pseudo code in our whole problem on this so that we get the identification of the whole problem. Maybe I can take the case 1 again, so that would be much more easier to visualize. We just discussed the case number 1, just running the pseudo code on that part. You have 1, 2, 4, 5, and 6. So what we can do is we start off with a counter that is initially C equals to 1. So we have one element only. I know 1 is the initial counter that I'm starting off with. And then answer variable also starts with 1 because I know I don't have any answers below 1. You cannot get an answer 0. You of course will try to save at least one element in the end. So one element can be a starting of point as an answer. And when you say that start off with this one answer, you can begin your pointer over here at this location because you want to check for the element and its consecutive element. So either I would have taken AI and AI plus 1. I am just taking AI and AI minus 1. Again, this is an implementation difference. You can implement it however you want. So this becomes my ith element and I want to check it with the I minus 1th element. So now what do I say? I say, okay, is 2 minus 1, that is A of I minus A of I minus 1, is this difference less than equal to k? Yes, if this is, in this case, of course, this is 2 minus 1 is less than equal to 1. In this given problem, we did not note this down. K was 1, so right? So that makes sense, is less than equal to k. So I know I'm going to increment my counter. This counter becomes 2. And this would mean that, okay, now the segment you are talking about is basically this one. And of course, this has a length of 2. 2 elements are satisfying your consecutive condition. So now simultaneously, I also maximize my answer variable with the maximum of answer and this new value C, that is 2. So answer becomes 2. Then when I move over here, this is I and this is I minus 1. What happens is now you know that this condition is not true. 4 minus 2. Remember, I had already sorted the array. Of course, this array was already sorted, so not a big deal. But I would have sorted this array. Now I know 4 minus 2 is the difference of 2, which is not less than equal to k. It's actually greater than k. So I would want to reset my counter back to 1. This is the reset process over here. And I know I cannot maximize my answer anymore because even if I do that, 2 is not less than 1. So 2 remains 2. Answer is still as it is. Now my pointers move again. This becomes I. You can say this becomes I and this becomes I minus 1. Now what happens? You say, okay, 5 minus 4 is less than equal to k. Yes, it is. So this becomes 2 again. Now is answer changed? No. Maximum of 2 and 2 is still 2. So answer doesn't change. Now you move the pointers. This is a fun point. This comes to I and I minus 1. 6 minus 5 is actually less than equal to k. So counter becomes 3, which dictates that you found a 3-lengthed segment. Now this is of course more than the previous answer stored. Automatically gets maximized and your value shifts from 2 to 3. And now you finally end the loop, you come out and you know that your answer stored over here is 3, which is very good for you because now you know that the largest subarray which had less than equal to k differences maintained in MD consecutive pairs is 3. So the number of elements I would want to remove is total, that is 5 minus this value, that is 3. So I get the answer as 2. And this is what I can print. That would mean 2 elements removed. So now if you apply this pseudocode, which we just discussed on all the other cases, you will actually see that all the sample outputs check out. And this is the whole idea for the problem. Let us move on to the coding part and see how do we implement this out. So just have we discussed the pseudocode, that is what I'm doing over here. I take the array input. Before that I do the input of t, n, and k, that's very basic. And then input of the array. So this is basically taking inputs. Then I sort this. So I have sorted the array over here, right? And then I take a counter variable, that is 1, and then an answer variable, which is 1. To be specific, I should not name this answer. Maybe you can name this something different. Maybe something like largest. You can say this as largest length. This would make much more sense. So now you have a counter variable. You have the largest length, which you're trying to maximize. It starts with 1. Then your loop starts with 1. And then you check for AI and AI minus 1. These are the consecutive elements. Are they less than equal to k? Yes, increment your counter. Else, so this is increment portion. And when you say that, okay, this condition was not fulfilled, then you say, okay, reset counter back to 1. And every time besides this if and else check, you maximize this largest length variable with the counter variable. So when you come out of this loop, n minus largest length is actually your number of variables, number of numbers which you actually remove from the array. Alright, so this is the whole problem. Let us discuss the time complexity now. You have an n order over here to take the input, so this is very basic. Then you actually have the sorting over here. Now sorting the array is going to run in n log n. So this kind of runs in n log n order, or log base 2 to be specific. I write this as n log base 2 of n order. And then you have a n loop over here. Again, inside this, I have very simple constant checks and maximizing part. So this is not going to affect. But now since n log n was the superseding term, so I can note the time complexity as n log base 2 of n. And now this is very, very simple to think that this is going to work. Why? So if you go back to the problem and see that n is given in 2 into 10 raised to 5 order. So I can note this down as O of, you can say 2 into 10 raised to 5 order. And then this is log base 2 of 2 into 10 raised to 5 order again, 2 into 10 raised to 5 to order again. And this means you are somewhere getting around, like, log base 2 of 2 into 10 raised to 5 order is somewhere around 18 operations. So you can get this as 2 into 10 raised to 5 and into 18 would effectively give you, or to be very specific, you can take this like a 20 operations just to make your maths easier. So 20 into 2 into 10 raised to 5, which gives you 40 into 10 raised to 5, which gives you 4 into 10 raised to 6. So this is 4 into 10 raised to 6 order. Now this is of course very, very good because we discussed a time complexity that we wanted to be in 2 into 10 raised to 8 order, as we discussed over here for the time complexity. Will this work? Of course, this is going to work and it's going to get me an accepted solution. Now, what about the space complexity? I am only using the space of the array, that is 2 into 10 raised to 5 order. So that is all I'm doing in my space complexity. And this is what finally wraps up the problem. Very clever problem, I should say, right? The whole idea of first imagining the rearrangement part is very, very useful. Definitely it's a power. That's why the intuition goes towards that part only, because it's free. Why not utilize it first? And it makes sense that if we sort, we get lowest differences in adjacent. And then all we need to find was the largest part, and total minus largest is the numbers we remove. All right. So I hope you liked the video. Thank you for watching.